In this video, we will learn how to solve application problems using systems of linear inequalities in two variables. Systems of linear inequalities arise in many applications. For example, the target zone for heart rate during exercise, the capacity of a room for an event, and the return on investments. Now, let's discuss an application problem involving systems of linear inequalities in two variables. A school has invited 200 students to a graduation party. The fixed costs, such as transportation and entertainment, are $2,000, and the variable costs, such as food and drinks, range between $25 and $40 per person. Assuming at least 100 and at most 200 people attend, graph the cost of the graduation party as a system of inequalities. To graph the cost of the graduation, we begin by writing four inequalities. Since we can assume that between 100 and 200 students will attend, we can begin with the inequalities x is greater than or equal to 100 and x is less than or equal to 200. Next, we write inequalities for the cost of the party. We know the fixed costs are set at $2,000 and the variable costs are per guest. So we can write the inequality y is greater than or equal to 2,000 plus 25 times x to represent the total if the variable costs are kept to a minimum. We can also write the inequality y is less than or equal to 2,000 plus 40 times x to represent the total if the variable costs are at the maximum. Finally, we can graph these four inequalities on the same coordinate plane and identify the area within the bounds of each line. The solution, or shaded area in the graph, implies that the party cost will be between $4,500 and $10,000. In economics, the point where the supply and demand curves intersect is called the equilibrium point. Let's take a look at a graph of a supply curve and demand curve. Consumer surplus is a measure of the amount that consumers benefit by being able to purchase a product for a price less than the maximum they would be willing to pay. Producer surplus is a measure of the amount that producers benefit by selling at a market price that is higher than the least they would be willing to sell for. Let's use what we've learned to solve the following problem. Write a system of linear inequalities corresponding to the producer surplus for the following supply and demand equations. Supply: P equals 30 plus 25 hundredths times x. Demand: P equals 120 minus 5 hundredths times x. In both equations, x represents the amount of particular items sold and p represents the producer surplus, or amount of money that the producers benefit by selling at a market price that is higher than the least they would be willing to sell for. Step 1. Find the point of intersection. Set the supply and demand equations equal to each other. Isolate x on one side of the equation by subtracting 30 and adding 5 hundredths x from both sides, resulting in 3/10 times x equals 90. Dividing both sides by the coefficient yields x equals 300. This is the x-coordinate of our equilibrium point. Step 2. Calculate supply at the point of equilibrium by substituting 300 for x into the supply equation. P equals 30 plus 25 hundredths times x. We chose the supply equation to evaluate because producers supply while consumers demand. Thus, P equals 30 plus 25 hundredths times 300. Multiplying 25 hundredths and 300 gives 75, which when added to 30 yields 105. Now that we've determined the point of equilibrium and that the producer surplus is the area above the supply curve and below the equilibrium price point, we can write the system of inequalities as follows. P is greater than or equal to 30 plus 25 hundredths times x. P is less than or equal to 105. X is greater than or equal to 0. This system implies that there are at least 0 items produced, that the fixed costs are set at $30 and the variable costs are 25 cents per item, and that the producer surplus is no more than $105 when variable costs are kept to a minimum.